Hi, this is Tim from London, and today I'm going to talk about the 5 most important synthesis modules. And to do so, I'm going to go back to my youth. Back in the day, I had a Roland SH-101, and I'm going to use this TAL Baseline, which is an SH-101 emulation, just to describe the elements of the synthesizer. I like the SH-101 because it's laid out in a really simple kind of way. It makes it really quite apparent what's going on with the synthesis. So, if we have a look at the various elements of the SH-101, we start off with the performance controls, so the keyboard, but also things like pitch bender, modulation devices, and the portmanteau. Other elements that are important, we've got the voltage controlled oscillator. A little different on the SH-101 because as well as having a VCO section, we also have a mixer. And what's actually happening is that the SH-101 is generating a number of waveforms all the time together, and you get to mix them into different levels. Just to the right of the VCO and mixer, you'll find the voltage control filter, or VCF, and that's the element that's going to shape the sound of the note. And again, to the right of that, you've got the voltage controlled amplifier, and that's the bit that's going to give us the volume over time element. In addition to that, we also have two other elements. The first one is an envelope section. We'll talk about that in a second. And then the final element that's important is our modulator, or low frequency oscillator. And so those are effectively the 5 key elements: the modulator, VCO, VCF, VCA, and the envelope. So let's lay those out slightly differently. We've got the performance controls, and that's really going to kick the noise off. We've got the voltage controlled oscillator, the voltage controlled filter, and the voltage controlled amplifier. So let's think about what's going on here. Back in the days before MIDI, the keyboards, the physical keyboard, when you pressed a note, you would generate two voltage controls. One would be called a control voltage, or CV, and the other one was a gate. So the CV was telling you the pitch of the note, depending on the voltage, and the gate was telling you effectively the note on and note off information. So those two things together would then tell the voltage controlled oscillator what's the pitch of the note that we want to play, and when's it got to start, and when will that stop. We come across to the voltage control filter, the VCF. That's the bit that's now going to shape or colour our waveform. So the VCO is generating hopefully a nice thick amount of timbral information, and the VCF is then going to start to shape that. And then the final element is the voltage controlled amplifier at the back end, and that's going to tell us how's the note going to start, how's that sound going to develop in volume over time, and when's it going to finish. And then finally, of course, that creates an audio output that goes off to our amplifier. The two other elements that we've got to think about now. The first one is a modulator, a low frequency oscillator. And that can actually be applied to all 3 of those main elements. The low frequency oscillator is going to give us a frequency variation of a matter of hertz or cycles per second. And if I apply that to the voltage controlled oscillator, I get my vibrato. I apply it to the filter, what I can do is modulate the frequency, cutoff frequency for the filter. And what that'll do is allow it to pump up and down, and I'll get that wah, wah, wah kind of effect. If I apply it to the voltage controlled amplifier, I'm going to get a stutter or a pulse. So the low frequency oscillator will emphasize the volume and de-emphasize the volume on and off. So that's how the modulator fits in. We've also got the envelope section. The envelope section tells us how a parameter is going to develop over time. So again, if I apply that to the voltage controlled oscillator, what I can do is change features of the waveform over time. Now, the key waveform for an SH-101 or the TAL Baseline is a square wave. And the parameter that we can change on that is what we call the pulse width. So if you like, it would change a square wave into more like a rectangular wave. So that width of the pulse we can change over time, and that'll help the timbre of the note to develop. If I apply it to the filter, then I can change the filter settings over time, so I can look at a filter sweep open and close again. And if I apply it to the voltage controlled amplifier, it allows me to affect the volume over time, so I can get that nice sharp attack at the beginning of the note, and then that can decay away. And even when I release the key, the R part of ADSR tells me how long the note's going to sustain for after that point. So those are how my key elements fit together. I've got the VCO is telling me how the frequency the timbre of the note is going to start. The filter shapes it, and the amplifier gives it some volume control, and then I can look at changing that over time with the envelope, or I can change it in a vibration kind of way with the LFO. Of course, with the performance controls, I've got some other key things that I can do. So the keyboard itself on an SH-101 will actually route round to the VCF. And the reason for that is if you imagine the cutoff frequency being right in the middle of the keyboard, that would imply that the notes below that cutoff frequency, so the lower notes on the keyboard, I'll get the full frequency spectrum of. But if I go up the keyboard, all of a sudden the note could appear above my cutoff frequency, and so I'm going to lose the volume, the impact of that note. So on the SH-101, there's a keyboard control that allows that filter suite to change with the control voltage. So I make sure I do pick up some of the high frequency. So let's step across and have a look at the SH-101 or the TAL Baseline in real life. Okay, so I've got an instance of Ableton Live open. I've got my TAL Baseline synth in the centre, and I've got a spectrum analyzer down here at the bottom. And let's step through some of the controls that we've got. So I've got the keyboard, and so I can play notes on the keyboard, and that provides my performance control, and that generates the impulse now that goes into my voltage controlled oscillator and source mixer. And you remember I said earlier that actually a Roland SH-101 or the Baseline is permanently producing a number of different waveforms altogether. You'll see I've got a pulse waveform slider here, I've got a sawtooth wave slider here, and then I've got something called a sub-oscillator and a noise slider. So let's see what happens. At the moment I've got a sawtooth wave set up, and you can hear the noise and you can see the effect down on the speakers, on the frequency analyzer. If I increase a pulse wave mixed into that, you can hear how the tone develops. And I also have the ability to put in what's called a sub-oscillator, and that'll put in this case, 12 semitones below or an octave below, and it gives a thickening to the sound. And wherever I go on the keyboard, I'm always going to get 12 semitones below. I have the ability to put in some noise. And you see how that really thickens up the sounds that the voltage controlled oscillator is generating to then put into the VCF, the voltage control filter. The pulse width, I'll just dial up the pulse wave, and we can hear what happens when we change the pulse width and see how that affects the tone that we get. So once I've got a nice full sound, I can now look at the effect of the filter. You can see the frequency, so the cutoff frequency. You can see how that changes the spectrum. I can look at boosting a resonant peak just ahead of the cutoff frequency. You can see how that affects. And so that's the voltage control filter. The amplifier at the end, at the moment I've got it set to a gate. That simply means when I press the note down, I get a full sound. When I release the note on the keyboard, it switches off immediately. So that's my voltage controlled amplifier. But I've got some other settings involved here. So let's start with the voltage controlled amplifier and work our way backwards. The first thing I could do is set it to envelope control. What that allows me to do is to use this section at the end here to dial in, if you like, a delay in the attack. So you can hear the note getting louder over time. I can change the release settings. So as well as a slow fade in, I get a slower fade out as well. And that's using the envelope controls here. I can use those envelope controls in the filter as well using this slider, and that allows me to change the way that the filter opens up over time. So hopefully you can hear a wah as the filter starts to open. And again, back down in my voltage control oscillator, I can use the envelope to change the pulse width over time. So if I just dial up, there's my straightforward pulse. If I change the pulse width, you hear the note develop because the envelope setting is now changing the pulse width. So that's one way of changing all of these parameters using envelope settings, but of course I've also got this nice modulator over here. And what the modulator allows me to do is to apply a bunch of different waveforms at a certain frequency rate. And I can apply that to the voltage controlled oscillator, and that will allow this pulse width now to change over time. Or I can apply that, switch that off, I can apply that to the filter to get a wah effect. And so I've got a bunch of different controls that I can change my voltage controlled oscillator, filter and amplifier with. So, in summary, we really just have the basic building blocks of a synthesizer being the voltage-controlled oscillator, the voltage-controlled filter, and the voltage-controlled amplifier. We talked about the modulator, and we've also talked about the envelopes. So, that really brings my presentation to an end. I found it really useful. I hope you have too. Thanks very much for listening.